Okay, hello everyone again. So last time we talked about the model and the real numbers in our real world. So we're going today to talk about real numbers. So here the real numbers. B1, B2, real numbers. Okay. So in the beginning, before we start talking about the real numbers, we're going to talk about the types that make up the real numbers. Okay. So in the beginning, I can say there is a types of numbers. Okay, there is a types of numbers that make up the real numbers. The real numbers system. So in the beginning, we have to know the real numbers is like a huge block of numbers. Okay. This huge block, we can break it up into pieces. These pieces, if we collect it together, we make up all the system of the real numbers. So in the beginning, we're going to talk about the first type of numbers. It's called the natural numbers. Natural numbers. What is the natural numbers? Who have idea about natural numbers? Anyone know about natural numbers?
I think they are positive integers, like whole numbers.
Positive integers. Like, what about 1/2? Is a natural number?
No, it's like 1, 2, 3. Those
Exactly.
are natural numbers.
So natural number is starting by 1, 2, 3, 4, 5. All these positive numbers to infinity is called natural numbers. It's not containing any fraction like 1/2 or 1/3 or any numbers like that. So natural number is starting from 1, goes to infinity, like 1, 2, 3, 4, 5, and all these numbers. The second types of numbers is called integer numbers. Integer numbers. What is the integer numbers? Any idea about integer numbers? What is the
Would be a
integer numbers?
whole number with negative or positive.
What about 1/2
No.
and 0?
Yes, 0, yes.
Well,
What about negative 1/2? Is a natural number? No. So I can say integer numbers is a natural numbers with the 0 and with the negatives. I mean, with the negatives like -1, -2, -3, -4, -5 to minus infinity, and the 0 and all natural number 1, 2, 3, 4, 5 to infinity. So I can say here all negative numbers comes from minus infinity to -3, -2, -1, 0, 1, 0 here, 1, 2, 3, and to infinity. So all these numbers are called integer numbers. So they are the natural number from 1 to infinity, and the 0, this one, and also the negative of the natural number, -1, -2, -3, to minus infinity. The third type of the numbers, the 3, called rational numbers. Rational numbers. Any idea about rational numbers? Any idea about rational? What is the meaning of rational numbers?
Doesn't it include fractions or decimals?
Yes, they are include or not include?
They include.
Include, yes. So I can rational numbers are, I mean, like rational numbers are the ratio of integers. What does that mean? Like I can say the rational numbers can be written as R equal m over n, such that m is integer number and n also is integer number, but n here not equal 0. So I can say here m and n, both of them are integers, and in the same time n here not equal 0. Why n not equal 0? Why n cannot be 0? Can I divide by 0?
No.
No, I
No.
cannot. So if I divide by 0, they give me undefined number. That's why n here cannot be 0, because they give me undefined. Yes. Laila, she said, give you undefined. Exactly. So I cannot divide by 0 number. So example for rational number like r equal 1/2, 1 over 2 is a rational number. For example, 3 over 4 is a rational number. And also 5. 5 is a rational number. Is a 5 is a rational number?
No.
Yes, is a rational. Why? Because I can divide it by what? By 1.
1.
Yes. So all natural number and all integer number are rational numbers. Why? Because all of them I can divide it by 1. So the 5 is a rational number. So this is equal, here I can say the 5 equal, here 5 equal 5 over 1. So this is mean is a rational number. Also the same things for negative, minus 2 over 5 is a rational number, minus 7 over, for example, 11. Okay, so all of them is a rational number. So here I get the question, I'm so confused. Again, rational number is a number can be written as of the form fraction, m over n. M and n, both of them are integer number, and n not equal 0. Why? Because if n equals 0, they give me undefined fraction. The rational number, for example, 1 over 2, 3 over 4, and the 5 is also rational number. Why? Because the 5 I can write it as 5 over 1. So it will be like as a fraction. Yes. Any number can be written as fraction, they called rational number. The fourth question here, the fourth set that make up the real numbers is called irrational numbers. Irrational numbers. What is the irrational numbers? Is any number I cannot write it as fraction m over n. So here I can say the numbers that cannot written as or equal m over n. So any number I cannot write it as m over n is called irrational number. Who will give me example for irrational numbers?
Decimals.
Like what?
I guess 0.1.
0
Actually,
by
no, or maybe pi, for example.
yes, exactly like pi, because 0.1 I can write it as 1 over 10, and 1 over 10 is a rational number. So irrational number, I cannot write it as a fraction. For example, pi I cannot write it as a fraction. Pi equal 3.14 and decimals 5, 6, 7, 8, like a lot of decimals. So this pi I cannot write it as fraction. So pi is irrational number. Another example is the square root of 2. So here I can say example for irrational. Pi, number 1 is pi. Number 2 is the square root of 2. Why? Square root of 2, I cannot write it as fraction. Number 3, square root of also 3. Also, this one cannot written as fraction. Another example is 2 divided by pi. This is also cannot written as fraction. I mean here not over pi, sorry, like pi square. Yeah, pi square. This is not a rational number. Okay, now, so all of this, I can define it as a diagram. So the diagram would be look like this here. All this box is the real numbers, will be divided into 2 pieces. This is piece for rational numbers and the other piece for irrational numbers. Here for rational numbers. And inside the rational numbers, we have the integer numbers. This is the integer numbers. Inside the integer numbers, we have the set of the small set is the natural numbers. So this one here, irrational numbers, irrational numbers. Irrational numbers. So this set here is irrational numbers. This here, the box here, is called rational numbers. Rational numbers. Inside the rational, we have the integer numbers. This here, the set here, is called the integer numbers. Make it more bigger. Here, integers. And inside the integer, we have the natural numbers, the small ball, natural. And all this called the real numbers. Here, real numbers. So I can say it here, all numbers here are called real numbers. The -2 is a real number. -2/5 is a real number. Pi is a real number. The square root of 3 is called a real number. Square root of 2 is a real number. So all numbers here called real numbers. Any question? Anyone has a question? So I can say real numbers are made up by all these previous sets: natural number, integer number, rational number, and irrational numbers. Okay? Now, properties of real numbers. We have some properties of the real numbers. Okay. Here, properties of real numbers. Okay, properties of real numbers. First property is called the commutative property. Number one, commutative property. What is this? The commutative property okay, commutative properties. This property says if I have two real numbers like a plus b, this is equal b plus a. And the same things for multiplication. This is for addition, same things for multiplication. A times b is the same as b times a. Commutative property says the order does not matter. I mean, if I add a plus b is the same as by adding b plus a. Same things, if I multiply the first one by the second one is the same as multiplying the second one by the first one. I'm going to give example for this. For example, 2 plus 3 is the same as 3 plus 2. And the same things for multiplication. 2 times 3 is the same as 3 times 2. Because in the same things, in the both side, they give the same answer. 2 plus 3 is 5, and 3 plus 2 is 5. Both of them, they give the same answer. And the same things for multiplication. 2 times 3 is 6, and 3 times 2 is 6. So it's called commutative property. Yes, they give the same result from both sides. If I add the first one to the second one is the same as adding the second one to the first one. Same things for multiplication. Multiplying the first one with the second one is the same as multiplying the second one with the first one. Again, a and b are real numbers. Here I can say a comma b are real numbers. So the commutative property are achieved in the real numbers. Second property is the associative property. Associative associative property. I mean, for that, if I have three numbers, A and B and C, all of them, A and B and C, are real numbers. A plus B parentheses plus C is the same as A plus parentheses B plus C. And the same things for multiplication. AB parentheses times C is the same as A times B plus B times C. Sorry. So this is said, here does not matter which two we add first or multiplying first. If I add the first two numbers, if I add the first two numbers to the third one, is the same as adding the second one and third one and the result added to the first one. Same things for multiplication. I'm going to give example here. So example, for example, if I have 2 plus 3 plus 5 is the same as 2 plus 3 plus 5. And same things for multiplication. 2 times 3 times 5 is the same as 2 times 2, 3 times 5. So if I add the first two numbers to the third one is the same as adding the first one, I mean adding the second one and third one together, then the result added to the first one. This property is called the associative property, and this is achieved in the real numbers. Any question? Makes sense? Okay, if you have a question, okay. What about the others? Any question for the first and second property? Is it clear?
It is clear.
Okay. Okay, all good. So let's go to the third property, the last one. Okay. Third property here, number 3, is called a distributive property. Distributive. Oh, okay. I'm going back. Okay. Now, distributive property says if I have a number A multiplying by two numbers, but I mean A multiplying by the sum of two numbers, B plus C, is the same as we distributing the A inside the parentheses, A times B plus A times C. So this give me A times B plus A times C. This is called the distributive property. Same things, if I do addition, B plus C times A, same thing, we distribute the A inside the parentheses like this. So I get equal, I mean A times B plus A times C. It's actually B times A, but I know it's commutative. So B times A the same as A times B. So I can, because I know by the first property, the commutative, B times A is the same as A times B. Same things here, C times A is the same as A times C. So this property here, the first one and the second one are the same. If I multiply from the beginning here, is the same as if I multiply in the back. Okay, example for this. Example. So 2 times x plus 4. This is the first one. And here, number 1. Number 2 is a plus b. I mean a plus, let's, okay, I'm going to do it later, this one. Who will do the first one?
I could
Where's-
do it.
Okay, where's the answer?
It would be 2 times x plus 2 times 4.
2 times x, exactly. So I distribute the 2 inside the parentheses. So I get 2 times x plus 2 times 4. And what is 2 times 4?
8.
8. So the answer is exactly 2x plus 8. So this is easy. I'm going to give more harder. So before I give the harder one, I'm going to give the property. If I have, for example, a plus b, okay, times x plus y. So I'm going to do here 2 times of distributing. So I'm going to distribute the a with the x and the a with the y. And again, I distribute the b with the x and the b with the y. Yes. So this is equal, will give me here equal a times x and plus a times y plus b times x plus b times y. Yeah, exactly, like FOIL. Okay, let's give example for this one. Example. So my example is 2 plus 3 times 4 plus 5. What is that equal by using the property? Who will do this one?
I'll do it.
Yes, okay.
It's going to be 2 times 4 plus 2 times 5
2 plus times 5, okay.
plus 3 times 4 plus 3 times 5.
Exactly, thank you. So again, we distribute the 2 inside this parentheses, 2 times 4 and 2 times 5. Same things for 3. 3 times 4 and 3 times 5. So now simplify the answer. 2 times 4 is 8. This is equal 8 plus 2 times 5 is 10. 3 times 4 is 12. And 3 times 5 is 15. So the answer is 8 plus 10 plus 12 plus 15. They give me 45. Because here we have 25, 23, 35. Yes, they give me 45. Any question? Yeah, we can do it the same things, but I'm going to use this property. By using this property, I can combine 2 plus 3. So I can say 2 plus 3 is 5 times 4 plus 5 is 9. So I can set 5 times 9, they give me 45. But I would like to use this property, distributing property, multiplying the a with the inside the parentheses and multiplying the b inside the parentheses. And both of them, they give the same answer. If I do the combining this, adding both of them, and adding both of them, and multiplying the two parentheses. This is correct, Michelle. Yes, I prefer to do it the same like this in the test, using the same property. In the test I give you direct. I told you use this property, a plus b between parentheses times x plus y parentheses, using the same property. So you have to apply the property in the test. So in the test, I should to give you the property you have to use. Okay. Can I move to the next slide?
I have a question.
Yes.
So let's say in the test, do we have to do it the same way you did it like this, or we can do it in different way, but the result is the same?
Yes, this in the test I will told you use the property. I will type the property. I will let you know what's the property you have to use. So I told you use this property, and I will type this property to know which property I mean. Because you can give me the same answer with different way, I mean. So in the test I have to clarify what the property I need. Okay. Again, now let's go to the different properties. It's called the addition and subtracting properties. So here's addition and subtraction. So we have another properties is the addition and subtraction properties. Okay, so the first one is said the number 1 here, minus 1 times a is the same as minus a. For example, if I choose any real number instead of a, for example, 7, minus 1 times 7, they give me minus 7. Number 2, you can write example here, example, minus 1 times 7, you give me minus 7. Number 2, the second property says minus times minus a times a minus a, they give me a. Why? Because I multiply the minus with a minus inside the parentheses, they give me positive a. Same things, easy example. I can take any number, example minus times minus 7, they give me 7. Okay, third property is minus a inside the parentheses times b is the same as a times minus b is the same as minus outside the parentheses ab. Okay, Same things, I can get any number instead of A and B, for example. Choose any real number, for example, -2 times 3 is the same as 2 times -3 is the same as the negative outside for A times B. I mean, A is 2 times 3 times 3. Here, 2 times 3. All this, they give the same answer. Why? Because -2 times 3 is -6, and here they give me the same things, -6, and here they give me the same things, negative times 6 is -6. Property number 4, if I have parentheses -a times -b is the same as ab. Why? Because minus times minus is positive. So example here, you can say -2 times -3 is the same as 2 times 3, 2 times 3. Why? Because here they give me 6 again, and the other side they give 6. Property number 5 is negative outside, open parentheses, a plus b. They give, we can distribute the negative inside the parentheses. They give -a, -b. So here, the same idea like before, the negative can distribute it inside the parentheses. -a, -b. Give you example. For example, if I choose -2 plus 3. Okay, so the negative I can distribute inside the parentheses. They give me -2 and -3. Okay, so in the both side they give the same answer because 2 plus 3 is 6. Multiplying by negative, they give -6 here. Same things here. This side, I mean, like 2 plus 3 is 5, -5, and the same things here in this side, -2, -3, they give -5. Okay, property number 6, the last one, says if I have minus outside, a minus b, I can again distribute the negative. They give me -a plus b, and this is the same as b minus a, because I know the sum is commutative. From here, a plus b is the same as b plus a. Same things here, -a plus b is the same as b plus -a, and b plus -a is the same as b -a. Example, the same things. Easy example. For example, negative of 2 minus, I mean, 3 minus 2. So again, distribute the negative inside the parentheses. They give me -3 and plus 2, and this is the same as 2 minus 3. Okay, any question for these properties? No questions? Okay, so all of them clear. So here again, the same idea. We're going to distribute the negative inside the parentheses. Yeah, the negative goes inside here like this. Okay, example, general example here. Okay, examples. A negative outside of x plus 2. Which property is that? Negative outside x plus 2. Which property of the from 1 to 6?
5.
Exactly. Look to the number 5 and look to the question. Negative times, open the parentheses, x plus 2. Look to the number 5. Is the same things. So in number 5, we distribute the negative inside the parentheses. I get negative a, negative b. Same things here. I get negative times the first term is x, negative second term is 2. So I get negative x, negative 2. So I distribute the negative inside the parentheses like this. Now the second one, b. Question is negative outside x plus y minus z equal. Who will do this one? Negative x. Who will do? I said here negative x minus y plus z. This is correct. Same. Yes. Yes. Okay. But I can do it step by step. So I distribute the negative inside the parentheses like this here. So I get negative x, negative y, negative open parentheses, negative z. Now I'm going to use another property for this one. Which property is the same for this part? If you go back, which property is the same for the blue part, this one
The second
only?
one.
Second one, look to the second one, minus open parentheses minus a equal a. So the same idea here, I can set here properties number 2, but here I use the property number 5. So to go from here to here, property number 5, for this only is property number 2. So continuing, this is equal minus x minus y, and using property number 2, negative, negative, they give me the positive one. So plus z. This is step by step, how using the properties. Okay, any question? Is it clear for the properties? No questions? Okay. Okay. Now let's go to the multiplication and division. So we finish the properties for addition and subtraction. Now we're going to the multiplication and division. The same things I'm going to give another properties. We don't have to memorize all these properties, but we have to read it and you know how to use it. You don't have to memorize all of them, but you have to read the properties and you know how to use it. For example, if you see something like that, minus 1 times a, you have to know this is equal minus a. Okay, same things for the second properties. Minus times parentheses minus a. The minus and with the minus, they cancel each other. They give me positive a. Now, the properties, now the multiplication and division. Okay, same things. We have some properties for multiplication for a fraction. So first property says, number 1, if I have fraction, this property is for fraction only. Here I can say can set here for this. Pop. This for fraction. Property is for fraction. This only for fraction. So the first one, if I have the fraction a over b multiplying by another fraction c over d, so in general, I multiply the numerator with the numerator and the denominator with the other one. Okay. Thank you. So the same things here, I multiply a with the c, a times c, over b times d. For multiplication. For second properties is a over b divided by c over d. So in this property, I write the first fraction is a over b. I change from division to multiplication. The sign I have to change it, cross. And here I have to take the inverse for this fraction. I have to invert the second fraction. So it will be d over c. So again, I keep the same fraction for the first one. I change the division to multiplication. I flip here, or I take the reciprocal for the second fraction. Third one. If I have a over c plus b over c, the answer will be a plus b over c. So if I have the same denominator for both sides for the same fraction, for both fraction, I have to do sum for only the numerator. So again, here the denominator are equal c. So I have to add only the numerator, a plus b. For the fourth one, if the denominator are not the same, for example, a over b plus c over d, I have to cross multiply. What does that mean? I have to multiply a with the d, c with the b, and b with the d. So this is give me here a times d plus c times b over b times d. Okay, let me give you example for the first one fast. Example here. For example, if I have 2 over 3 times 4 over 5. So they give me, we multiply the numerator 2 times 4, give me 8 over 3 times 5 is 15. Second one, if I have 2 over 3 divide by 4 over 5. Who will do this one? Who will do the second one?
It would be
Yeah, one. One of you will do second one of you will do the third one. Who will
it'll
do the
be
second one?
2 over 3 times 5 over 4.
2 over 3 times 4, 5 over 4, right?
Yeah, 5 over 4.
Okay, and what is the answer here?
10 over 12.
10 over 12, yes. I can simplify it by dividing both sides by 2, or I can keep it the same things. So I divide both sides by 2, they give me 5 over 6. The third one, who will do the third one? the other student. Here we have 2 over 3 plus 5 over 3.
It would just be 7 over 3.
7 over 3. Why? Because the denominator are the same, is the same c, c. So I have here the denominator is a 3, and the same things for the second fraction is 3. So the answer is we have to sum only the both numerator. 2 plus 5 equals 7 over 3. Now for the fourth one example, the numerator is different. 2 over 3 plus 4 over 5. Who will do it?
I can do it.
Okay, what is the answer?
It's 2 times 5
2 times 5.
plus 4 times 3
Okay, over what?
over 15. 3 times 5.
Oh, 3 times 5. Okay, let's simplify the answer. 2 times 5 is
10.
10 plus 4 times 3 is
12.
12 over 15. Okay, 12 plus 10, they gave me 22 over 15. Okay, any question for the first 4 property? Okay, we have 2 more properties. I have a question here. No, it's not a decimal. The dot here, I'm sorry, the dot here is multiplication, is not decimal. We multiply here. And the same things for the back. Layla. So the dot here is mean multiplication. We multiply here, cross. This is mean, cross. We multiply, not decimal. Same things for in the back. The dot mean multiplying. Okay. So again, the dot means multiplying. Here, the same things, multiply, we multiply. It's not a decimal. Okay, okay. Now the last 2 property, number 5, says, if I have A times C over, for example, B times C, we can cancel the C with the C, the common factor. So we can cancel C with the C, and the answer will be A over B. A over B. So we can cancel the common factor. For example, for that, here example, if I have 2 times 3 over 5 times 3, I can cancel the 3 with the 3, this canceling each other. Or I can cancel this with this, and the answer will be 2 over 5. This is called canceling properties. Number 6 is if A over B is the same as fraction C over D, this fraction is the same as this fraction, then, for then must, A times D is the same as A times D is the same as B times C. This one times D is the same as B times C. I'll give you example for that. Example. 2 over 3 is the same as 6 over 9. This fraction is the same as this fraction. Why? Because if I multiply 2 times 9, 2 times 9 is the same as 6 times 3. Yes, here is that A times D and B times C. A times D exactly equal b times b, c times b, or b times c. So we multiply this a with the d is called the cross multiply, a with the d and the c with the b, cross multiply, yes. So here, why this fraction equal this fraction? Because 2 times 9 is 18 is the same as 3 times 6 is 18. So the both answer here, they give me 18, and this is give me 18. So I mean this fraction equal to this fraction. This fraction is equal to other fraction. It's called cross multiplying or cross multiply. If I give you another fraction, is 2 over 3 the same as, for example, 4 over 5? You have to check. You have to do the cross multiply. You have to ask yourself, is 2 times 5 is the same as 4 times 3? Is 4 times 5, 2 times 5, I mean 2 times 5 the same as 4 times 3? The answer is no, exactly. So here no. So this is mean this fraction is not the same as the second fraction. So the answer here again is no. Why? Because the cross multiply is not satisfied. The cross multiply is not satisfied. So when do the cross multiply, they're not giving the same answer. This is me, the fraction is not the same. So here, because 2 times 5 is not the same as 4 times 3. That's why the fraction is not the same. Okay, any question? No questions? Okay. Most of the time, we're adding the two fraction by doing the cross multiply when the denominator are not the same. I mean, can I move to the next slide here? Okay. So sometimes we do addition for two fraction. For example, we add 5 over 36 plus 7 over 100 over 120. So when we add two fraction, like I said, the denominator are not the same. So we have to do cross multiply, right? But cross multiply is not easy all the time. It's not easy to multiply 5 times 120 because the number is huge. And also the same things here, 7 times 36. The 36 is a huge number. So we need calculator for this. But as we know, we cannot use calculator in the exam. So the best way here to use to find the addition is we have to use the least common denominator. Least common denominator. I'm going to explain how we can use the least common denominator. So by using least common denominator. Least L common C, denominator D. It's called LCD. LCD. Okay, so to do this one, first things we have to bring the 36 here and we have to factor it. And the same things for 120, we have to bring it and we have to factor it. Then we have to multiply both sides, both fraction, by the least common denominator. Okay, let's do it. So what's the factor of 36? And the same things for factor of 126, 120. What is the factor for 36? How I can factor the 36? Any idea how we can factor the number 36 from high school?
3 times 12.
3 times 12?
Yeah.
This is correct, but we can also factor the 12. Can you factor the 12? Here I get here answer 6 times 6. This is correct, but we can also factor the 6. I need it in the simplest way.
So 3
Yes.
times 3 times 2 times 2.
3 times, let me do it. What you said? 12
3
times
3 times 3 times 2 times 2.
times 2. 3 times 3 is 9. 9 times 4 is 36. This is correct. Why? Because 3 times 3 is 9. 9 times 2, 9 times 2 times 2, like 9 times 4 is 36. Or some student, they said 6 times 6. This is correct. So I can say here, I will show you how it's correct. I can say 36 is the same as 6 times 6, but I have to factor the 6 again because the 6 is equal to 2 times 3 for the simplest way. And the same things for the another 6 here. This is correct, like times 2 times 3 is the same as the same in the above. We order it 3 times 3 times 2 times 2. So all of them correct. Zainab 3, 4, 6, 9. This is not correct. The correct answer is 3 times 3 times 2 times 2. This is the factor of the number 36. Or like here, Michael, he said, or she said, 2 times 2 is 2 to the 2, but we don't need it like power because we need it like a factor without power. This is correct, 2 times to the power 2 plus 3 to the power 2. This is correct, but we need it like in this way. Factor in this way, so without power. How we can factor the number 120? Factor of 120. How we can factor it? Who will give me the idea? 120. Here I get 5 times 3 times 2 times 2, 5 times 2 times 3 times 2 times 2. This is all of them correct. But can you give me how you think for this? How you start thinking? 12 times 10. Yes, this is correct. Exactly. So I can say this is equal 12 times 10. Now I can factor this 12 as 6 times 2 or 2 times 6, and the same things for the 10 is 2 times 5. And I can factor the 6 as 2 times 2, 2 times 3, right?
Yeah.
This is give me 2 times 3, and this is the same things because it's factored. The 5 is the same thing. So actually I get 2 times 2 times 2, 1 times 2 times 2, and times 3 times 5 times 3 times 5. So here the same things, I will order it by the smallest one, 2 times 2 times 3 times 3. So here 2 times 2 times 3 times 3. This is equal 2 times 2 times 3 times 3. Now, the idea for the smallest common factor, we have to cancel the common factor. So we're looking for this factor, for this one here, and we're looking for this one. And we have to cancel the common. I mean, we have to cancel the similar number. So here we have 2, we cancel it with this 2. The other 2 we can cancel it with the other 2. The 3 we can cancel it with a 3. Here the left is 3 only. Here we left 2 and also 5. This is left. Okay. Now we go to the question. We multiply the 36 by 2 and 5 because 2 times 5 is 10. So we multiply this by 10. And we multiply the 5 the same things, 10. And we go to the other fraction here. We multiply by the least common factor is 3. We multiply this by 3. We multiply this by 3. This makes sense? Is it clear? This is very important, the least common denominator. Is it clear what I did? Again, I factor the 36, the denominator, 2 times 2 times 3 times 3. Why? Because this is, and the 4 I can factor it more, is 2 times 2. The 9 I can factor it by 3 times 3. The 120 is equal 12 times 10. I can factor the 12 as 2 times 6 and the 10 by 2 times 5. I can factor the 6 as 2 times 3. So I get here now 2 goes down. The 6 is 2 times 3. The 2 goes down. The 5 go down. So now I have to order it. So I get 2 from the small numbers. So they give me 2 times 2 times 2 times 3 times 5. Now we cancel the common. We cancel the 2 with the 2, the 2 with the other 2, the 3 with the 3. Now left here is 3, and here is left 2 times 5. 2 times 5 is 10. So we go here to the 36. We multiply by 10 for both sides. The 120 we have to multiply whatever it's left from the 36 after we factoring and we canceling the common factor from the 36. So here we multiply by 3 for both sides, numerator and denominator. Here we have to multiply by 10 for both sides, numerator and denominator. So now what we get? 5 times 10 is? What is 5 times 10?
50.
Is 50, 50, over 36 times 10. How much? 360 exactly. Plus 3 times 7,
21.
21, over 120 times 3
360.
is 360. So look now, the denominator are the same, 360. So we're doing the same properties like before. What is the property? If the denominator number 3, if the denominator are the same, we have to do sum for the numerator. So now here I get 50 plus 21 over 360. And the final answer is 71 over 360. Here I get the question, what's the reason for multiplying by 10 on the left and multiplying by 3 on the right? Why cannot be the other way around? Okay, the reason for that is to make the denominator are equal. Look at the denominator now. After we multiply this by 10 and we multiply this by 3, we made the denominator are equal 360. So it's easy now to do a summation for fraction have the same denominator. Abu Bakr. Okay, it makes sense. So the reason after we do factoring and we cancel the common factor, I mean we cancel the same numbers, we multiply this by 3 and we multiply the other by whatever remaining here, 2 times 5 is 10. The reason is to make the denominator are equal, 360. So when we make the denominator are equal, now it's easy to do summation for different, like it's easy now to do summation for fraction have the same denominator with different numerator. Look, the denominator now is the same, 360 for both sides. So now it's easy to do the summation. Here we cannot do the summation with different denominator. And again, a cross multiply is hard here. Why? Because the numbers in the denominator are huge numbers. 5 times 120 is too much huge. And the same thing, 7 times 36 is a huge number. And multiplying the 36 with 120 is big, huge number. So the easiest way is using the least common denominator. Any question? Make sense? So now we can do addition for any fraction by using the least common denominator or by using the cross multiplying. Make sense? Okay, so now let's go to different topic. It's called the sets and intervals. Is the last topics will be in this section. Now let's go to, can I move to the next slide? Any question for the least common denominator? Is it clear? Okay, all good here. What about the other student? Okay. Clear. So now let's go to the sets and intervals. Sets and intervals. Okay. First of all, I don't know if some of you know what's the mean of sets and what is the mean of intervals. Who know what's the mean of sets in high school, or what is the mean of sets in math? What is the mean of sets? Do you know what is the mean of sets? Group numbers? Yes, this is a group. Yes, sets means a group. Like we have big group of numbers, but the numbers are known here. Like I can tell you 5, 6, 7 group of numbers. What about intervals? Who's bigger, sets or intervals? Do you know with bigger sets or intervals? Intervals, yes, intervals is bigger than sets. Okay, let me give you the definition of set. The interval is more bigger than set. Sets is a collection of objects. But in math, we're not going to use object, we're going to use element. So in math, I can set the object here. The object in math called elements or elements, element. For example, I give you example, set A. I have a set A. Set A has some element like 1, 2, 3, 4. I can say number 1 is an element of the set A. Number 1, okay, I can say it like this. 1 is an element of the set A. And the same things, number 2 is an element of the set A. Same things for 3 and 4. But what about 5? Number 5 is not an element of the set A. So here I can denote it as, I can say here, A1, number 1 is belong to, by this symbols, belong to A, or an element of A. And the same things here, I can say 5 is not an element of A. This is what you have to know about set. But okay, now for the intervals. Now for intervals. So if I have, so for intervals, we have to know we have two kinds of interval. Is called the closed interval and open interval. We have two kinds of intervals, is closed interval, and we have open interval. Okay, so I'm going to explain what is the meaning of a closed interval and open interval. The sets is like object is a known 1, 2, 3, 4. This all of them called set. But interval we have closed and open, and the interval is more larger than set because they have. I will show you in the next slide. Can I move to the next one? Can I move? Okay. So what is the meaning of a closed and open interval? So closed interval here, can said closed interval. We can denote it by something like this. Here, close, this notation, close. Here we have element A, like number 5, for example, comma, B. And here, this is the mean is close, like this. This is mean we have the set of the number from A to the B, and A and B, both of them are inside the interval. are inside the set. I mean, for this one, all, this is mean here, I have to say this is mean. This is mean. The set of all numbers or all element or numbers from A to B, and A and B are included, and both of the endpoints, I mean, for the endpoints is the same as A and B. For the both, for the endpoints, here endpoints A, comma, B are included. Are included in the set. So close interval, the notation is close from A to the B, and I mean, is all the element from A to the B, and A and B are included inside the set. Yes, is like the endpoints of the lines. I will show you, for example. I'm going to give you example, but after I'm explaining the open interval. What's the meaning of open interval? So for open interval, instead of this notation, we have to use different one, is mean like this, open, parentheses like this. A, comma B, and close like this. Again, this is mean, the set of all numbers. I mean, all numbers, all real numbers. Here, there's a numbers like fraction or like decimal. Like when I said the interval from 2 to the 5, I mean like 2.55, like 2 point, for example, 0.0005. You know, I mean like a lot of numbers between 2 and 5. We have 2, 2.1, 2.2, 2.3 to the 5 is like a huge infinity numbers between A and B. That's why the interval is bigger than sets. For the set, we have to specify the element, like saying the set A equal 1, 2, 3, 4, 5, for example, or 2, 3, 5, 6, like this. But the interval is more huge. So open interval is when we define it as open parentheses between A and B. This is mean the set of all numbers from A to B, but the endpoint is not included, exclude. So A and B is not in the interval, and A comma B not including, not included. So A and B not included. For example, we have example here, nice examples. So here, for example, I have example. Yes, you have a question? Anyone has a question? So for example, like this, 2, 5. So I mean here for all numbers from 2 to 5, and the 2 and 5 are include the interval. Mean, this is mean here, x, I mean for x all the values from 2 to 5. Or I can specify, define it as x such that x between 2 and 5, and the 2 is included inside the interval. So this is equal here. I mean for x, all the values between the 2 and 5, and both of the 2 and 5 are included. That's why we put here equal. For open interval, I mean like open 2 to 5, and the same things is equal x such that x between 2 and 5, and the 2 and 5 not equal. We don't have to put the equal sign. Is it clear?
Yes.
Okay, another notation. So let me give you a table, because there is not include. Yes, because is not include the 2 and 5, we're not putting the equal sign. So is not equal. Here we have to put the equal. So focus in the equal sign. We have to put here equal, equal, but there we don't have to put the equal. I mean, the endpoints is not included in the interval. Okay, the last things before we leave. So I'm going to give you this table. Can I move to the next slide? Okay. So the table is, suppose I have here. So notation, some intervals, 1, 2, 3, 1, 2, 3. So here notations. Here set descriptions. And here's the graph. We have to know how is the graph for each interval. So notation and set description. So for the first notation, suppose I have the interval open in parentheses a comma b and close at b. This is mean is this equal x. This is the same as said all the value x such that x between a and the a is not included. We don't have to put the equal, and is equal at the b. So the graph for this one is line like this, and at a is open circle. This is at a, and the closed circle at b. Close. I mean for close is included. Is it clear the first one?
Yes.
Is it clear? Okay. If you have a question, you can ask your question. For the second notation, 1 second. So for the second notation, suppose is something like this. Open parentheses, a comma infinity, and close. Same things here, minus infinity to b, and close the interval. For the second one, this is mean from the number a to the number infinity. I mean to the infinity, not in a number infinity. So I can specify this one by, I can define it as x such that a like all the number x is greater than a, like this. All the numbers are greater than a and a not equal, without the equal. And the same things for the line. So when you draw the line, here's line. So at A is open circle. We have open circle here. This is A. And all I have to put arrows like this. All numbers is greater than A, like this. Here, open circle. For this one, the same idea exactly. So all the numbers from the negative infinity goes to the b. The limit is b. We stop at b. So I mean x such that all the numbers is smaller than b. So I can say it here, x, all the numbers is less than b. So at b I have to stop. Again, the graph, something like this. At b, this is b, is a closed interval because we have equal, and all numbers less than b. This is b. Shouldn't the sign be the opposite way? The sign be the opposite? No, I can't say. Yes, I can say it like here. Do you mean like this one? This is equal the same like x such that b is greater or equal x. This is the same. Do you mean this, Natasha? Yes, this is correct. Okay. Let me give you an example, the last example, because we have like 5 minutes. This is small example. It's not hard one. So the example is describe this notation. What does that mean here? What does that mean? The interval, closed interval from 1 to 2. And I mean from -1 to 2 at 2 is open. Who will do this one? Who will do the set description for this one? What is the set description for this?
Would it be x such that -1 is less than or equal to x, and it would be less than 2?
Yes. So here equal, and this is 2. Thank you. This is correct. Now, how we can graph it fast? Do graph. Going to graph, show the line. At the -1 is a closed circle. So at -1 would be closed circle like this. At 2 is open circle. At 2 is open circle. So here we have -1. Here we have 2. And we put a line between both of them. This is line. Make it more better. Here's the line. So this is a line between the both small balls. Okay. So we're going to stop up to here today. Next time, I'm going to give you more examples for this one, and I will move to the next section. Okay, so the student who did not sign in inside the sheet, please don't forget to sign in inside the link in the chat box. Okay, thank you so much. See you next Wednesday, right? Okay. Have a good day.
You too. Bye.
Thanks. Bye.